Okay, today I think we're going to be not even rewriting, but writing some functions to actually handle our dropping and picking up of stones. Now, I say this because we've got dropping and picking up stones here. So look at, we've got it in movement event 2. Movement event 2, we can drop and pick up stones. Now this whole chunk is pretty much the exact same anytime we drop a stone. Now the only thing that's different between this and the movement event 3 version or movement event 4 version, the only thing that's different is the space at which we're placing the stone when we drop it. The index of the stone where we're actually dropping it, the dropped in movement origin, like this depends on which grid and which movement event it is. But basically we can write a function so that when down is pressed and mouse stone occupants is greater than 1, it'll do all of our drop stone logic. We would just need to pass it in two things. We need to pass it in the occupant at which we need to drop it into, and we need to pass it in the variable to be the correct variable to be incremented so that we can limit how many we pick up. We can only pick up what we've dropped, and we only know that based on how many we've dropped in a specific grid at a specific turn, so they need to be different variables. So for movement event 2, in that case, it's the dropped in movement origin, but I think we can just write a function that takes in a parameter of an occupant and variable to increment once dropped. I'm a little hot. I might switch into less clothes, but let's see. So the whole goal of this episode is to condense all of this into one function that says drop stone, occupant, movement origin, right? And then here, pick up stone, occupant, movement origin, instead of these 20 lines or whatever this is. Because when we're in a move event 4, we do the same exact thing. We do the same thing, except that we drop it in first movement instead of movement origin. Just like up here is dropped in movement origin. That's why we need to require a second parameter so that we don't accidentally keep incrementing the dropped in movement origin. But look, that's 20 lines, another 20 lines we can get rid of, and then in our movement event 5, it's another 20 lines we can get rid of, and another 20 lines we can get rid of. And then when we're doing movement event 6, actually movement event 5 would have it, we do the same thing. So that's another 20 lines saved and another 20 lines saved for the pickup. So if we can implement this one fix, we can save maybe 100 lines of code. And then it makes it easier to scale for the movement 6 and movement 5 and movement 6. So it might be high hopes to try to get that done here in the next 30 minutes or so, because I gotta leave soon, but we can try it. What I'm gonna do is copy over all of our drop stone logic for our movement origin right here. I'm going to copy all this over, and I'm going to use this as the sort of tester to kind of compare and make sure we're not doing anything different with any of the times we drop a stone. Because when we drop a stone and pick up a stone, the mouse occupants should stay the same. All that logic should stay the same. The only thing that's really changing is which grid we're actually dumping the stones into. And that requires a specific variable to be incremented upon dropping a stone. So that's why we'll need the 2 parameters. But it should be fairly straightforward otherwise. So up here with all of our other functions, I'm going to make a new function. And it's not within this function, but here. Okay. So we're going to have a new function. And that function's going to be called DropStone. Excuse me. And the parameters, it needs an occupant, and it needs a dropped in grid variable. I'm going to paste our template for our movement, dropped in movement event right here. Actually, we're going to comment this out so that we can rebuild it with the correct variables, but we're going to keep it there so that we can paste in our second movement and judge and make sure that we're trying to do the same thing upon every DropStone function call. So the first thing we want to do in our DropStone function is play the DropStone sound, because a stone will have dropped. And we hide this function call in the space that we have all of this code, so that we still are only calling this if our mouse occupants is greater than 1, you know. Oh, and you know what? That's the only other difference is our movement stone 1. The first time, once we select movement origin, there is one more difference which makes it tricky, because the when we're selecting our first grid, we're not allowing the player to drop all their stones, because otherwise that would be a non-movement essentially. So like, yeah, we initialize movement by picking up 5 stones, and then if we drop all 5 stones and lock in that movement, nothing will have happened, and the turn will be over, which we don't necessarily want to be true. But we can just add in our first movement conditions where we say if down is pressed and actually I think it already is fixed like that. If our occupants are greater than, if our mouse occupants are greater than 0, meaning 1 or above, then we'll be able to drop a stone. And then for the rest of them, it's if it's 0, because we can drop all of our stones and we can lock that in as a legal move. So here is where we need our occupant.occupants to get incremented. So we will increment our occupants, that's so stupid, our occupants, possessive occupants, plural. Then we will decrement our mouse stone occupants, because we're swapping stones. That makes sense, because this is a DropStone function. Now, the next thing we do is assign what we call a movement index. No, an occupant index. and that global variable is actually set to the occupant, to the updated occupants. So we increment it, and then this index is one higher than the grid you used to be before we dropped a stone in, meaning that the occupant index we're dropping a stone into will be a stack order one higher than the topmost stack, giving us that pyramid rendering. So we set occupant index to the updated occupants, and then we do our magic. And our magic is we take our occupant, we go into our members table, and at our occupant index, in the field stone color, we're assigning the mouse stones at the lowest mouse stone stack order index in the field of stone color into it. So we're taking the stone color of our bottommost mouse stone, putting it into the occupant index of our occupant. Now we need to do 4 variables. Now we need stone type, and then we need stack order, and then we also need the original stack order so we can retrieve the original size of our mouse stones. Okay. Now that we've copied over from our mouse stone members into our occupant members, we need to delete the members that were in our mouse stones to effectively move it. So we say members at that lowest mouse stone stack order at that field of stone color gets nil, and we need to do it for all of those values. So stone type gets nil, stack order gets nil, and original stack order gets nil. Okay, the last thing we need to do is update our dropped in grid variable. So on the first movement, it would be this. On the movement origin, it would be dropped in movement origin, but we need to define it in terms of our parameter so we can choose which variable gets incremented. So our dropped in grid gets incremented. And then our lowest mouse stone stack order also gets incremented upon dropping a stone. Now that should be our function right there. So we need to make sure we pass in the occupant to be dropped into. We need to make sure we pass in the appropriate grid that will be incremented, and then lowest mouse stone stack order is regardless of a drop stone or a pickup stone, because we only have one set of mouse stones, yet we have different amount of occupants in our grids to drop stuff. So this is why our lowest mouse stone stack order doesn't need to be a parameter, because it doesn't change. Because we should index our lowest mouse stone stack order up if we drop a stone in any grid, really, because that's the lowest mouse stone stack order is maintaining what piece to drop. So let's see if our DropStone function can be replaced with our movement origin drop logic. So right here, if movement event 2 right here. So this is all the old stuff. Now if you look, this is exactly what we've got. We've got the play sound, we've got update our occupants, then we got our occupant index and our moving, and then our nullifying, then our reset. So this looks like it should work. And this milestone occupants greater than 1, meaning if we have 1, we cannot drop a stone, so that should be right. So I'm gonna put all of this commented out and see if we can just replace like this. We use our DropStone function. We use it on our occupant of grid movement origin row, movement column. So movement origin row, movement origin column, and then we pass in the dropped in grid, which in this case would be dropped in movement origin. So we turned these many lines into one function call like this. Now, whether or not that works is a different story, but if we're in movement event 2 and we try to drop a stone, that should be getting executed. So we'll see if it's working. So movement event 2. So pressing down should drop a stone in this green highlight, and it does, and it does, and we can't drop more than 1. And we cannot pick any up at the moment, which is kind of weird. Dropped in movement origin doesn't seem to be getting updated. Let me see if our dropped in movement origin is on our debugging. Dropped in movement origin, no. Dropped in first movement. We need a dropped in movement origin on this second page debug real quick. So we'll just do dropped in movement origin. So drop movement origin, and we need our dropped in movement origin variable. And now we should be able to see, I'm thinking we can't pick up any stones because this dropped in movement origin is not incrementing correctly. Let's test that theory. Now if we drop 1, we press down once, that should be 1, which it is not. So it is in fact not working. So something we're saying in our function call. We're saying in our function call, we're passing in a dropped in movement origin variable, dropped in movement origin, which is the one we want to increment. And in our declaration, we're saying that the dropped in grid gets incremented, yet that's not the case. So maybe do we need to do some reference to self here? Now, I don't know if we need to declare any parameters. I don't think we have to do that. I'm just a little confused why the dropped in movement origin line right here isn't getting upgraded or incremented. Now maybe we have to say something like, no, I don't know. The fact that that doesn't work makes me not know how the parameter was working in the first place, so. Dropped in grid, dropped in grid. So dropped in movement origin should be the one getting incremented. So why is that not the case? It's very close. We're just not updating this dropped in movement. It should work otherwise though, so we're really close. Look, dropped in movement origin at the bottom there does not increment upon pressing down, meaning we can't pick up any. So how do we do that? How do we allow this? Do we say, like, can we pass in a, this is silly, but we pass in which movement event it is or whatever? I don't know if we can just say that. We're close, we're close, we're close. So what if, oh, you know what? Okay, I know what's happening. We're incrementing our dropped-in grid, which is a copy of the argument that gets passed in. We're not writing this out to the appropriate parameter. I thought this would edit the parameter itself, but it's just, I think it's just updating. So like if we put a dropped-in grid down here, if we put dropped-in grid, that will probably do it right. Let's see. So that drop MO is actually dropped in grid, and it's not working. So it looks like we don't have access to that variable. So what the heck? I think that's what's happening though. Let's go back to I gotta use the bathroom. I'll be right back. No revelation about how to fix our problem. I think I'm right in that once we, like, I don't believe this, because this this is able to work, we're able to pass in an occupant and modify a value within that occupant. So how come we can't pass in a variable and modify that variable? Are we for sure calling the function correctly? Dropped in movement origin. That's the one that needs to get updated. Now, if we don't pass this in, does it yell at us? Yep. Trying to perform arithmetic on dropped-in grid, which is a nil value. So it needs a dropped-in grid. Now, what if the dropped-in grid was the dropped-in movement origin? How come that doesn't work? It doesn't crash there anymore because it has a variable to... Look, yeah, dropped-in movement origin is still 0. I don't get it. How come we can modify this one and not modify this one? Dropped-in movement origin, which is our dropped-in grid parameter. Now we're saying dropped-in grid. Now for when we update our... would it matter that this is a... I don't know. That wouldn't matter, right? I'm just looking at our capital O occupants was working. Their lowercase dropped-in movement wasn't, so... I don't know. Still not working. So what do we do? I think we have to say, shoot, I don't know. I don't get why we're able to modify these other values. If we can't modify our dropped-in grid. Now the only difference is... No. Maybe a quick Google search could help us. I just clicked on the first one, which is awful. Like, do I have to return the dropped-in grid value or something? Do we have to say something like we return the value so it's not just local to this function? Well, we don't have to do that on any other field that we're updating, because look, we're treating our occupant the same thing. All we're doing is assigning a new value into a certain field by calling it with the parameter, and that's all we're doing with our dropped-in grid. So why is it not working? Really don't know. whatever reason, that second parameter is not getting updated. Still not working. Now, I'm just gonna say, what if this is called option? Okay, and if we pass in a 1, meaning if our option parameter is equal to 1, then we're not going to be modifying dropped-in grid. We're going to be modifying dropped-in movement origin. That should work. I don't like that we would have to do something like that, because that means we have to hard code in every single option based on what number was passed in. But if we're function call, we pass in a 1 for our movement origin, that should work. So here, instead of this, we just pass in option 1, which should be the first, it should be dropped in movement origin, and then we should be able to pick up stones with our old logic. So let's see, dropped in movement origin 0, now it's 1, now it's 2, and that means we can pick up our stones as well. So looks like we just have to code in some, unless I find out another way to do it, we have to kind of pass in our option here. So like, I would say second argument is space to is grid occupant to drop stones into. So look, we turned all of this into one line. So let's do the same thing with our pickup stones. So we need to write a pickup stones function. So we'll go to where we have our DropStone function. We'll give ourselves a second function called PickUpStone. Now this is DropStone, and then we have PickUpStone. And our PickUpStone will also take in an occupant to pick up from, and it'll also take an option of which grid we are picking it up from, so we know how many we can actually pick up. So I'm going to paste our pickup logic so we can have something to judge it against, comment it out, and then build it again. And this should be the only time we need to copy and this prevents us from copy and pasting it every time we need to drop a stone or pick up a stone. We just call this function now. So that'll be nice. So sounds dot stone play the stone sound. Now we do this a little bit different. We update our occupant index first now, because occupant index is the field that we're picking the stone. Since we're picking up a stone, we're taking the member at our top field, which is our amount of occupants. So yeah, we don't have to do it after we update our occupants. We do it right now. So we assign it there right off the bat. Then we update our occupants to be decremented. So occupant.occupants gets itself -1. And then we increment our mouse stone occupants because we gain a stone. Now, then the magic, which is we take in our mouse stone members at our lowest mouse stone stack order, -1, one beneath our current stone. And we take that field and we're going to be putting into it our occupants dot occupants. No, our occupants dot members at our occupant index. Stone color, assigning it into there. And we do the same for our other 4 variables. Now stone type, stack order, and original stack order. And then we're replacing it with our occupants and our members occupant index field of the same type. So this is stone type, this is stack order, this is original stack order. Now we need to nullify the grid that we picked them up from. So this is actually our occupant. And we just we go to the member of our occupant index, which we assign it to be the topmost stone right here. So our topmost stone gets nullified from our occupant grid, which means we're taking it from our topmost stone location into our mouse stone members at 1 index beneath our current lowest mouse stone stack order. So if we've got 5 in our hand, stack order 5 at the bottom, we pick it up and it goes to stack order 4, meaning it would render it bigger. So let's continue to do this. We nullify the topmost stone, and then we need to do 2 things, which is if our option is 1, then we would need to decrement our dropped-in movement origin. And then otherwise, we just also need to update our lowest mouse stone stack order so we can pick up a stone beneath our new lowest stone. So there is our PickUpStone function. So now we still need to hard code in, just like we need to hard code in our other options. But that's not a big deal. So we'll try right here. Just make sure that we can paste it here. This is our grid at our movement origin again. So movement origin row and movement origin column. And then our option is 1. Right here, we don't need this function. We just run the function there. So now we should be able to pick up stones without our old logic in our movement origin. So let's just test that. So we can drop stones and we can pick up stones, and we're no longer using our old logic. So what that tells us is we can go ahead and expand this to be in our DropStone. If our option is 2, then we're going to increment our dropped in first movement. Else if our option is 3, Then we're going to increment our second movement, dropped in second movement. And then we're going to do this for our pickup as well. On the decrement side, else if option is equal to 2, then our dropped in first movement gets decremented. And then else if dropped in second movement gets decremented. Okay. Now that should be right. So let's go ahead and test or replace our other logics. So we're going to go, we replaced our movement event 2 logic already. We turned all of these lines into just this one line. So now we're going to try to do the same thing with our next movement event here. In movement event 4, we also drop a stone. If we take a look at what we're doing here, we do exactly the same thing. We play a stone sound, we increment our occupants, we assign our occupant index, we move over the values, we nullify the old values, we update our needed variables. So it's all the same. So we should be able to, as long as we pass in the right option. It's like, now this is a movement column. We're running this DropStone function on. So we say DropStone. The first parameter is our grid of our first movement column now. Our first movement occupant, because we're in movement event 4 at this point, meaning our option will be 2, meaning we're actually incrementing our dropped in first movement. And then we should be able to do this one as well for our pickup stones. Now, this is looking a little different. We're doing 4 things at the end here. Let's see what we're doing at the end of our function and make sure we're doing this. So here we're updating our milestone occupants. We're decrementing our grid occupants. We're decrementing our first movement and decrementing our lowest milestone stack order. And if we take a look at our function here of our pickup stone, the last thing we do is, yeah, we don't do like any of these things. So instead of doing our movement origin and lowest milestone stack order, what are we missing? Oops. That's our first one. But this is vilifying 4 members. Hold on a sec. I'm just gonna really just I'm gonna take this over there and compare it to make sure we're not forgetting anything. So under our pickup stone here, I'm just gonna paste this so I can see what we're doing. So right here we update occupant index and occupants, and we do that. God, it's hard to read. We assign our occupant index. Oh, see, we do it a little differently here. We're updating our milestone occupants later, which is fine because it's not used anywhere else, so it's just once, and then update our occupants, which we're doing here for the grid. Wait. Grid occupants gets decremented. We get grid occupants gets decremented here. Then we have first movement decremented, which we have down here. And then we have our lowest milestone stack order, which is here. So yeah, it should work fine. Should work fine. So we pass in the correct option. This is our first one. We just need to add our second one. So in our movement event 4, here, right here. Okay. So what we need is a PickUpStone function, and we need to pass in our first movement grid. So grid at first movement row, first movement column is our first parameter with an option 2 because we're trying to drop in our first movement, not our movement origin. And now we should be able to pick up and drop stones with our new logic with our function in movement event 4. So let's see if movement event 4 is working for dropping and picking up stones. So here is movement event 4, and we're able to drop all of our stones and we're able to pick them all up. So that's working. Now we can go ahead and maybe do our last one, which is a movement event 5, which is our second movement. So I'm going to turn off all of our DropStone logic. I'm going to place in our function we just wrote, which is DropStone function that takes in a grid, and the grid we're trying to modify, we're trying to drop stones into in movement event 5 is our second movement row, second movement column. And the option is 3 because we're trying to drop it in our second movement, not our first movement or our movement origin. So that should be the right code for dropping it, and then we need to pick it up. See, all of these code lines were used 3 times, and now we just have one function and we just call the function. I don't like that we have to pass in the option and then hard code that in the function, but it's really not bad. Pick up stone, we run on the grid occupant of our second movement row, second movement column, which should be the same as the pickup second movement row column. Yep. Then we pass in the option 3 for the dropped in second movement modulation. And then now we should have in a movement event 5 our drops and pickups limited on our able to drop a stone in the next movement, which is a movement event 5, and we can drop a stone. One mistake though, we're not. See how there's a little border when we drop this black stone there? Let's make sure if we drop in, look, I'm gonna use our old logic for a second here and see if it's busted there too. No, it is not. So we're messing up something here in our old logic where we're assigning the new stack order. We should be assigning the stack order, the original stack order. So the original stack order isn't being transmitted properly. Is that a fault of our code? Original stack order is being copied. So we're gonna have to figure that out. I'm not sure why it's not working, but I gotta get going. So we're gonna stick a tag in that for later. Why does function not apply? Correct. Stack control don't on empty occupant. That's an awful question, but I think I'll know what I mean by that. Okay, so we started implementing DropStone and PickUpStone functions, and then adaptive sizing busted. So we'll have to fix that next time. We'll push it. But yeah, I'll see you guys tomorrow, and we'll hopefully figure out what we're missing from there, and then we're probably at the point where we can not only get rid of all of our old code because we replaced it with some functions here, but we can get rid of our old code here, which is how we used to do things, and then we can kind of visualize our whole code base a lot easier. So we're coming up on the final stretch, and it's getting close, but we're not quite there, and we'll keep chugging along.